Okay, so part of today is just reminding us about things we already know from the quadratic unit, and then part of them is extending it into higher degree polynomials and what we should see from that. Okay, so if we have this function, f of x equals x squared minus 4x plus 3, to find the zeros, what do? We set it equal to 0 and factor. Whoops, wrong color. And so how would this particular function factor? X minus 3, x minus 1. So we know our zeros of the function are 3 and 1. So if we thought of this instead of as an equality, if we thought of it as an inequality, what would we need to do to solve it? So we know it factors to this, x minus 3, x minus 1. And the first thing we're going to do is we're going to pretend like this is an inequality, and let's go through the steps of what we would do to find where it is greater than or equal to 0. Hopefully you guys remember this from the quadratic unit. What we did was we would do a sign chart, and we would take our x-axis and we would plot our critical values. What are the critical values for this polynomial function? 3 and 1. And then what we did was we tested values which are in the different intervals. So the first interval would be from negative infinity to 1. So we picked something like 0. If I tested 0, do you see I get a negative times a negative, and a negative times a negative is a positive. And then we test something that's in this interval from 1 to 3, like 2. If I tested 2, I get a negative times a positive is a negative. And then I test a value in that third interval, like 4, and I get a positive times a positive is a positive. So we know the intervals over which this function has a positive value and a negative value, don't we? And we also know where it actually equals 0. Now, we can tie this into what we already know about graphing. Where would the zeros be from this graph? At 1 and 3. Does it pass or is it tangent at those points? It passes through. And what do we know about the end behavior? Even, positive, rise, rise. So just as quickly as we could make the sign chart, we could actually sketch a graph, couldn't we? And can you tell from the graph where the function is positive? Sure. We see it's positive here and it's positive here. Does that correlate to these positive intervals here and here? Yeah. Do we see where the function is negative? Sure, it's negative down here. Is that the same interval as this one? Yes. So do you see how the sign chart and the graph kind of work together? All right. So if I were to ask you to solve this one, where's this function greater than or equal to 0? Well, it is greater than or equal to 0 over what intervals?
Negative infinity to 1, and then 3 to infinity.
Good. And we're going to do inclusive because it says greater than or equal to. So this function is positive over those intervals. Now, what would change if instead of greater than or equal to, it just said greater than?
It would not be.
It'd just be parentheses, not a bracket.
Good. It'd just be parentheses, not a bracket. That's the only thing that would change. Okay. Now, what if this function, instead of being greater than, had been less than or equal to? Where is the function negative?
Brackets around from 1 to 3.
Good. Brackets from 1 to 3. And then maybe it's going to work here in a second. Good. Brackets from 1 to 3. And what if it had just been less than?
Parentheses from 1 to 3.
Parentheses from 1 to 3. So non-inclusive. Oh, thank you. I said it and then I drew it differently. Okay, so that just takes us back to what we did in the quadratic unit and reminds us of how we did these. We would set it equal to 0, and then we would factor. Okay, so let's take a look at a few examples and remind ourselves of other things. This one actually is going to be a U-try because it is just like what we did in the quadratic unit. So you try and solve that inequality?
Using the.
Yes. And do try to sketch the sign chart. Seen these quizzes. I meant to hand them back on Friday and forgot to.
Out of 50. You got a 100 here, that's right. So I got a 40 marks.
What on this one is asking for where it is just less than? Because it's zeros and 1 and 2. So would it be like 1.01 to 1.99?
Okay. So let's take a look at this one. All right, the first thing we have to do is move the 3x over. And so we're going to get x squared minus 3x plus 2 is less than or equal to 0. So this factors to what, guys?
X minus 2, x minus 1.
X minus 1. So we have it less than or equal to 0. So we'll take and we will find our sign chart here. What are our critical values for this problem? 1 and 2. And you picked 0 and you got out a positive. You picked 1.5 or something in between and got out negative. And then you picked a number over here and got out positive. So we want to know where it is less than or equal to 0. Well, it's equal to 0 at our critical values, right? So that interval would go from 1 to 2, where it is less than or equal to 0. If it just said less than instead of less than or equal to, it would look like this because it wouldn't include the 1 and the 2. Okay? All right. This is a 0. It's hard to see. Oops. So now we're going to apply those same ideas to our higher degree polynomials. So most of them we ought to be able to factor. What about this one? How would I start to factor this? Take the x out. Okay, now this is factored. But if I want the complete linear factorization, which is what I would need to find my critical values, I would want to go one step further. And so what would this factor to as a linear factor?
X squared equals 2.
So we'd say x squared equals 2. So what does x equal?
Root of 2.
Plus or minus root 2. So the linear factorization would look like this. X minus root 2, woo, and x plus root 2. Sometimes the maybe just has a mind of its own. All right, so on my number line for my sign chart. Okay, my critical values. Negative root 2, 0, and positive root 2. Those are the zeros I can see from there. Does everybody see all those? Now, we should know, and if we don't, let's learn that root 2 is about 1.4. You might say 1.41. And root 3 is about 1.73. So these we ought to be able to test around the roots without having to pull out our calculator. So like this problem could be on the no calculator page of your test. So we might pick like -2 for down here. So that would be a negative times a negative times a negative. A negative times a negative times a negative is a negative. And then plug in something in between here, like -1. A negative times a negative times a positive is a positive. And then plug in something here, like +1. A positive times a negative times a positive is a negative. And then plug something here, like 5. A positive times a positive times a positive is a positive. Now, for some of you, it's easier for you to think about, okay, I know how to graph this. I know about end behavior. I know about root behavior. This is a cubic, and it's positive, so it's going to fall, and it's going to rise. And all of these are linear, so it's going to pass, pass, pass. And where is the function positive? Do you see from root 2 to 0 right here, it's positive, just like here. Do you see from root 2 to positive infinity, it's positive? And where it's negative, it's negative. Do we see how these two go together? Okay. So if we think about root behavior and end behavior, this is going to give us a leg up on giving the intervals here. So where is it greater than 0? Well, it doesn't say equal to, so this function is greater, this inequality is greater than 0 from negative root 2 to 0, union with root 2 to infinity. Anything in those intervals will give us a true statement when we plug it in. Okay? All right. Now, this one. Factor that one for me. Okay, so when you did the complete linear factorization, how many real roots did we get? 1. So when we are looking at our critical values, we really only have 1 here, don't we? So we're really only putting -3 on here. So if we think about the graph of this function, we know it's going to pass through here at -3. We know it's cubic, and we know the end behavior. There's probably, looking at these complex, it's probably going to wiggle around up there somewhere. I don't know how. And it's going to look like that. Yes.
Just a question. Could you do synthetic substitution to get the factored form of that answer there?
Yeah. Well, a synthetic substitution is actually just going to take you to this. If I do synthetic substitution by -3, it would take me here. And then you'd have to set this equal to 0 and get x squared equals -1. Wow, I have got some severe delays going on here. And so that's where we'd get the plus or minus 5 from. Okay.
What's the significance of doing the numbers and putting in the numbers? Like, what is that?
That's just a different way.
But, like, what is that giving you?
It's giving you the interval over which the function is negative and the interval over which the function is positive. Now, if I did not think about the graph and I was doing here, where I'm going to plug my values in would be up here. I'm not going to plug them in here and force myself to multiply complex numbers because that would be painful and I shouldn't do that. So if I'm testing numbers, I'm going back up to where it wasn't complex to test. Okay, so where is this greater than or equal to 0? It's greater than or equal to 0 from -3 to infinity. All right, the last one I want to do together is this one. X cubed is greater than or equal to x squared. So, what do I do first? Subtract the x squared from both sides. And then I'm going to factor. So I take out x squared. And that gives that. Okay, what does this tell me is going to happen at this root?
0.
It's going to be tangent. So what does that tell me is going to happen if I draw in a sign chart? What do I know is going to happen around 0?
It's going to be equal to
It's going to be positive on
Whatever
both
sign is here, it's going to be the same here. It's either going to be positive on both sides of 0 or negative on both sides of 0 because it's tangent at 0. All right, so let's try one. If I pick -1, -1 squared is +1, and -1 minus 1 is negative. So a positive times a negative is negative. Now, we know it's going to be negative here, but we can check ourselves. If we plugged in a half, we get a positive times a negative is negative. And then if we plug in, say, 2, we get a positive times a positive is a positive. So if we think about this graph, it's going to bounce at 0 and then come back through at 1, doesn't it? So the whole function is negative on either side. So this says where is it greater than or equal to 0? So if I considered, okay, where it's greater than or equal to 0. Okay, who has an idea?
It's equal to 0 at 0.
It is equal to 0 at 0. Good catch. It's equal to 0 at 0. So part of our solution is just at 0. But what's the other part of the solution? 1 to infinity. Now, how would this change if instead of greater than or equal to 0, I just said greater than 0?
You wouldn't have 0.
You don't have this, and it would just be,
Parentheses.
okay, 1 to infinity. What about less than or equal to 0? So less than or equal to 0 is actually everything less than 1, and including 1, isn't it? Less than or equal to is all that. But what if it were just less than?
Parentheses.
It would be from negative infinity to 0, union with 0 to 1.
Could we write it as negative infinity to 0 to 1? Is that
No, we're going to use proper interval notation. Yes, sir.
What are the little squiggly lines around the 0 for
It means
greater than or equal to?
Just like if there was like one thing. It's just 0.
Oh, the braces? Yes, it's not an interval. So I couldn't use the interval notation. I had to use the set notation. It is just the 0. It's not an interval. Good question. Okay, questions? Any other questions? All right, I'm going to go ahead and pass out the homework. Now, the homework at the bottom of it has a couple problems where you actually have to use the calculator to find a 0. But if you use the calculator to find a 0, aren't you staring at the graph? Yeah. So the calculator problems are actually even easier because we're looking at the graph. We can tell where the function is positive and where the function is negative. Yes, you're doing the entire worksheet, but you have the remainder of class.
Have fun, babe. Have fun. Enjoy life. Don't cry. So, hashtag snow day tomorrow. Snow day Wednesday, actually.